Alright, so let's do example 6. Example 6 required, no, I already did it, so I'm going to cover it up. So y equals x squared, y equals 4, dot, 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 about the line x equals 3. So x equals 3 is this. So it is going to have, if it's revolving around this, you can imagine this spinning around, okay, it's got to have a dy slice. So here's our dy slice right here. Now, it's got to be in terms of dy, so in order to make this in terms of dy, we'll just do a little algebra here and just take the square root of both sides. So here we have x equals radical y. So that's basically what we have here. We have two radical y's. Okay, we got a radical y here, a radical y there. So really this is plus and minus radical y when we took the square root. But here's what we're going to do. Remember, we want to think in terms of area as positive. Okay, so if we wanted to consider the outer ring here, okay, the outer ring, if this is the center, okay, and it's going to spin around, this guy right here, this farthest point, has to be the outer ring. So if he is the outer ring, what we've got here is we have a distance here of 3. Okay, now we're ignoring this piece right here. Okay, we're ignoring the inside there. What we're doing is we're going from 3, and then that takes us to the y-axis. Then we're going to add the radical y here, just that distance. And that's going to be 3 plus the radical y that is that distance right there. And that would comprise the entire outer ring. And so we've got 3 radical y. Now the inside, okay, is we've got this other radical y that's going in this direction. So if I went from here to here, it would be 3. Okay, now remember, I'm doing the inner ring, so you're looking at the orange slice there. Orange slice, is that a power or something? But anyways, this right here, this would be 3 if we got rid of this piece here. So this is going to be 3 minus this distance, and that distance again is radical y, just like it is on this side. We added it to this 3 here, but here we're going to subtract it on this side. Okay, so we've got those distances here, and that's it. Now if you get this, you've pretty much got it made. You just have to remember that you got to keep your orientation here. So you're going from 0 to 4. Okay, you're going from 0 to 4, and you're just going to slice those, making sure that you get the formula for the outer ring, subtracting the formula for the inner ring. There's our pi, and calculate. Okay. All right. So the next one. The next one is also going to, let's see, it's going to revolve about x equals -2. So we're out here. And so what we want to do is we really don't care about whether or not it's positive or negative. We just want this distance to be 2. Okay, we know its location, and it's 2 away from from the y-axis. Now once we graph these, okay, you'll see that we've got the y equals 2 radical x. That curve is right here. You've got the other line, it's y equals x, that goes right underneath it. But from our perspective, if we're going to slice this way, the line is the one that's on the outside. So that's actually going to be our outside ring. Okay. Now let's see what we've got here. If I'm going to take the integral here, okay, now that would let me see if I can explain this. Okay, so if we look at the outer ring here, the integral underneath the line going this way, and by underneath I actually mean to the left, that integral right there will go up to the y-axis. Okay, so the outer ring is this distance 2 plus that other part that is from x equals 0 to x equals here, x equaling the line. Okay, so that distance right there would actually be 2. Now I know it's -2 here, but remember, we want the absolute value, right? We want that distance. We will add it to volume. Doesn't care about positive or negative. So we're going to have that 2 distance here, and then we will add that extra piece to get the outer ring. So that's why it's 2 plus y. Now, if we want the inner ring, okay, the inner ring is going to be 2 plus that little distance right here. I'm not going to zoom in, but that little sliver right there is 1/4 y squared. Where did he come from? Well, if we here y equals x, that's no big deal. Y is x. But if we want to find that distance right here in terms of y, we're going to have to do a little algebra here. Okay, and so we found that where's the work for this? Do I have the work somewhere? Oh yeah, right. Wait, no, where is it? Did I do this in my head? Okay, well anyways, here, let me do it real quick. You got 2 radical x. So if I want to, oh, there it is. I did it right here. Here we divided both sides by 2, so we got a half, and then we squared both sides, and that's how we got 1/4 y squared equals x. So we're going to go ahead and add 2 plus that, and that little piece is right here, that distance. Okay, that's the value there. So we're going to add that to the 2, which is this value. And again, we just do what we would normally do. We would take the outer minus the inner. And we're going from 0 to 4, so you did actually have to figure out where these guys actually intersect, okay? Because you're not explicitly told like you are here that you're going to stop at y equals 4, okay? You have to actually have to calculate where those two equal each other, and here's what I did right here. If y equals 2 radical x, then it also means that 2 radical x equals x because y is x. So if I actually just solved here, looks like we would square both sides. I would get divide by x, and then 4 equals x. So therefore, if x is 4 here, then plug x back into here, and so y would have to be 4. That's where they intersect at 4, 4. And so that's how we knew to go from 0 to 4. Okay, 0 up to 4. Okay, so that is a washer problem because we did subtract this distance there. Okay, we subtracted the whole. All right. Okay. This one right here. Where are we at? 7 minutes. All right. I think let's do these in pieces. Let's do this. I'll stop there and then do the last 3 in the last video.